Welcome to this session. We discuss a problem on Jacobian of implicit functions. This is our third problem. So we have x plus y plus z equals to u, y plus z equals to uv, z equals to uv w. So the problem is to show that the Jacobian of x, y, z with respect to variables u, v, w is u squared v. Now what we do, we rewrite this first equation as x plus y plus z minus u equals to 0. This one we write it as y plus z minus uv equals to 0. And this we write z minus u vw equals to 0. And then the left-hand side now becomes the functions. So this you call it f1, this we call it f2, this we call it f3. So let's formally give the solution. So solution. So we let, as we have explained there, f1 to be x plus y plus z minus u, f2 to be y plus z minus uv, and f3 to be z minus uv w. So the first thing is to find the Jacobian of f1, f2, f3 with respect to x, y, z. And by definition, this is this determinant, partial f1, partial x, partial f1, partial y, partial f1, partial z, and then partial f2, partial x, partial f2, partial y, partial f2, partial z, partial f3, partial x, partial f3, partial y, partial f3, partial z. This will give us, now partial f1, partial x is 1, y is 1, z is 1. x2 with respect to x is 0, with respect to y is 1, with respect to z is 1. f3, x is 0, y is 0, z is 1. And we are lucky, this is a triangular matrix, a triangular determinant whose solution is just the product of elements along the main diagonal, and the answer is 1. Next, we define the Jacobian of f1, f2, f3 with respect to u, v, and w, which by definition is the determinant f1 u, f1 v, f1 w, f2 u, f2 v, f2 w, and then f3 u, f3 v, f3 w. Now, when you put in the values, you should be able to get -1, 0, 0, negative v, negative u, 0, negative u, and negative v, w. Just check the functions. and negative u w, this negative u v. Also, we are still lucky because these are triangular matrix. So the determinant will be -1 by negative u, which is u times negative uv is negative u squared v. And then by definition, the Jacobian of x, y, z with respect to u, v, w will be -1 power 3, and then the Jacobian of f1, f2, f3 with respect to u, v, w over Jacobian of f1, f2, f3 with respect to x, y, and z. And this will give us negative, and then negative u squared v over 1. And should be clear that the answer is u squared v. So that is the solution. Thank you.